share the screen. All right, hello everyone. Let me start sharing my screen really quickly. So, welcome to the
Post DEFCON Pacific Hackers meeting.
Yes, so the post, it was a long week last week. So how many, by show of hands, how many people went to DEFCON? Oh, okay. Well, you know how I feel, right? Or how pretty much everybody feels. It was long, it was great. And there's a lot to talk about DEFCON, and there's a lot to talk about Pacific Hackers and where we're going from here.
Marco, if you're presenting something, we're not seeing it.
Well, I wasn't.
There you go.
Okay, cool. All right, so and can you see my
Yes.
I see the meetup one.
Okay,
Is that
good.
the one you want to show?
Yep,
Okay.
yep. All right. So so obviously if you're here is because you somehow find out through Meetup. That's what I asked some people. So this is our Meetup page. So this is where we post events every month. And that's how you keep track of what we're currently doing as far as the community wise, right? So this month we happen to have a great topic and a great presenter. I'm going to introduce her in a little bit. But let's talk about who we are. So I see a lot of new people. In fact, half of the room, you probably won't see them, but pretty much 80% of the people, yeah, you can turn around if you want. Pretty much everybody in the room it's new. And that's great because we want to have that exposure. We want to show you what we're doing so you can tell others and, invite them, right? So first things first, you see our new, actually, can you turn to the standee, please? We have two new standees. As you were coming in through the doors, we have a standee there that talks about our nonprofit, and also it talks, the other standee here talks about the meetup. So long story short, and since everybody's new here, how we started the Pacific Hackers meetup about 5-6 years ago. And it was just meeting like this every month, talking about, security related stuff, playing CTFs and so on. But we were starting helping people to get into jobs and, and so on. So we got to the point where a person say, well, why you don't do it at the bigger level? And I say, oh, why not? And how do we do that? The best way to do it obviously was as a nonprofit. So pacifichackers.org became a nonprofit exactly on August 1st of last year. And that's when we started actually doing, helping more people and stuff like that. And that's basically what we do now. So now, besides having the meetup, besides having the conference, which I'm going to talk about, we have an organization who's helping. The mission of this organization is, number one, diversify the cybersecurity industry. Number two, we want to fix the school system. So the school system, as you probably know or seen, they're not teaching the correct stuff. So when they graduate, they're not really ready to go to the workforce. So we want to show them what they really need to know in order to get a job. Number three is fixing the HR system. It's very insane when they, you see the job post saying, I want a junior analyst with a CISSP. Well, in order to get a CISSP, you need 5 years of experience in the field. So that's insane. So what we're trying to do here is make direct connections. So far, we already placed people from different backgrounds into the workforce. One at NASA, one into Intel, another one into a consulting company as a penetration tester. And again, I actually was one of how I got my job, a few years ago is I was giving a presentation on this same place, and my manager was there, and my presentation was my pretty much my ticket to to the job. That was my interview. So that was on a Sunday, and by Friday I was hired. So that tells you that meetups like this are very important because your potential manager or your potential coworker are already here, and then you just have to make the connection. So we need attendance. A lot of people choose to go hybrid because obviously COVID, and we really understand that. But we also see that, and especially at DEF CON, that we need the in-person, touch, because that's not going away. Okay. So, so I'm just showing you here the pacifichackers.org. We have a donation page. We're still obviously working on it. In fact, we're gonna launch the new page in a few weeks. But here's one thing. Sometimes it's not about just money, how you can help us. It's again, spreading the word, telling people about what we're teaching here, what we're trying to do here, and, kind of, go from there, right? So moving on, Pacific Hackers Conference. It is happening, and it is happening here at Hacker Dojo. So it's happening November 18 and 19. So in November 18, it's all trainings. So if there's 2 trainings, and actually, let me see. So there's going to be 2 trainings, the open source intelligence training and the enterprise penetration testing. If you're looking to learn any of those, topics, register. We're actually going to open registrations this Monday. So just look into that. Believe it or not, on the Eventbrite, there's the event for November 18 and 19. We already sold tickets, and we haven't even posted content or who's presenting or anything like that. But because we did this like in 2018 and 2019 and it was successful, people want this back. So that's why it was a last minute decision we took last month and say, you know what, I don't know how it's going to be. Let's just bring back the conference. And so it's happening this year. So that's another great thing happening. And again, Rod is going to be talking about it, and we have another presenter. She just gave a talk at the Red Team Village at DEF CON. Her name is Sandra, and also, she's been in other places. She has her own company, and that's what she does. Open source investigations for law enforcement. She trains law enforcement, military, and stuff like that. So you're interested in that, you can go there. If you couldn't make it and you miss the Zoom, well, we have the Pacific Hackers YouTube page. This is where all our videos are, and you've probably seen some familiar faces like this guy right here and this guy right here, and probably some other people. Oh, here you go. That's another star right here. Well, so before the pandemic, we were not recording our videos because for us it was very important to have that in person. Obviously, COVID came up, and we never stopped. We continue and to make it accessible to everyone, and that's when we actually start creating Zoom sessions and inviting and getting more people. So that was a good thing. The community never ended. COVID did not stop us, and that was a great thing. That's just telling us that people are willing to learn and willing to share knowledge and everything else. So that's great, right? So what we're trying to accomplish here, and this is where I'm moving with the DEF CON thing, is a few things. So a couple of weeks ago, we had a CTF, pre-DEF CON CTF, and the winner of the CTF won a badge to DEF CON. So these are also the type of things that we do. And in fact, I have the picture right here. So Alex, congratulations. So Alex won the first place on our CTF, and he won well, but you did it. The point here is that we want more people like Alex to come and well, first of all, share the knowledge and also prove yourself, and why not win something? Because this was just our CTF, but then if I just go back here to other things, we won first place at the Red Alert CTF at DEF CON. And this was huge because two teams from Pacific Hackers and Hack Miami got together. We have a member here. In fact, you were not on this picture because, well, but I took the picture on his behalf. Okay, so I helped him a little bit, but they did all the job. But here are some of the pictures. This team was formed out of people who randomly met. We just like The people in Miami obviously have never been here. And have you been Miami? Probably not. So they met at DEF CON, right? And then from there they say, well, let's form a team, let's play ACTF. They were not sure which one. They just picked one. It was a red alert. And here you go. We won first place. As you can see, here are the team XX won by 2,050 points, where the other ones were still on, below 2,000. And that was great. That was, a great accomplishment. In fact, I think I have the pictures from the event. Let me check.
I think it's in another tweet. Yeah.
I just downloaded them. So here we were already on stage, and that was actually a very great experience, because that's the showcase we want to show, right? We want to tell people that by coming here you learn something, and then when you go to DEF CON, whether you win in a CTF or not, going to DEF CON, form a team, and then you can represent us, right? So yeah, let's see what else. Anything else, Rod, that I'm missing? Oh, wait, he's actually the actual video. I don't know if it's gonna.
It's Max there.
Max is here. You wanna talk about it, Max?
Yeah, I like everybody to clap for Max. Max
Okay,
is our hero.
come here, Max.
All right. Yeah.
So here's the camera.
Please, step up.
Here, come here.
Hey,
Hi.
Max, how are you? Without this guy, we would not have won. Like, this dude cracked a batting oracle challenge in a day and a half. So please, everybody,
That was a lot of
give
fun. I
round of
stayed up all night
applause
for that
to
one.
Max. And that's his prize, right?
Yeah. So I want, since he wasn't there, what I want to do is I want to present, because I took his
Please.
the gift on his behalf. But this is what he won. He won an ICS kit, and apparently a pen and something, whatever.
I give him the coin to Phil, and then he's gonna give it to you so you can take pictures with it. Max, thank you very much
Right.
again.
So congratulations, man.
Yeah, thank
Here you
you.
go.
Thank
Yeah.
you.
Thank you.
Yeah.
Can't wait to pull this apart. All
Oh,
right.
wait, we have to.
Wait.
No, that.
Right. So I didn't mention there's a story with this. So there was an actual show in DEF CON with drummers and everything, and they were giving out this sword. So this became very fun. I got stopped by security many times because they thought it was real. So I just had it like right here, and I was wearing a hat and a cape. And basically they told me you have to put that in your room or stuff like that. And to the point where like I just went, here, it's not real. And yeah, they left me alone. But that was the story of this. So here you go. So, and it's here for anyone. If you oh, last but not least, so we release, so in your desk we have some flyers. We have the flyers for the, on one side, the nonprofit, the other one is for call for papers. If you're interested to being a speaker at Pacific Hackers Conference, please submit your talks. We want the local audience to get your, known. We have many people now, celebrities in the cybersecurity industry, who went through Pacific Hackers Conference 1 and 2, and now they're in bigger venues. We want the same for you guys. So
We're
please,
also CFP for training, Marco.
say that again.
CFP for training too. If you have an amazing training.
Oh
that we
yeah,
can-
yeah. Like I mentioned, we have 2 trainings right now. But if you have a training that, who knows, like you might want to present, hey, might as well make some money, and again, please let us know, and that'll be cool. So there's stickers, but also we have 2 t-shirts that we actually selling to raise money for the nonprofit. So I'm just gonna show it right here. So this is the first one, the one I'm wearing, and a lot of people are wearing. This is the Pacific Hackers one, the nonprofit, and let me see. This is the conference one. So it's 1 for 25, 2 for 40. If you're interested, we have t-shirts here, and yeah, otherwise, I think it's time for me to present a awesome presenter and an awesome topic. So you probably hear about the Flipper Zero. Well, I guess you can do a lot of things. There's one in the back. There you go. You can do many things with Flipper Zero, and I'm just gonna let Kaitlyn introduce her topic. But so she's been part of Pacific Hackers for many years. She's been giving talks about satellite hacking, hardware hacking and stuff like that. And without anything else, I'll just let you present. So I'm gonna turn off my camera right now. We're gonna switch computers, but yeah. So Kaitlyn, come over.
Woo! So okay, we can unplug that computer.
Yeah.
So I have. I am You'll have to mute. Okay, and then I'm going to unmute. Oh, no. Oh, I'm unmuted. Okay, perfect. Start video.
Click on the arrow first, because that might be
Yeah. Oh my goodness. Okay, it works. Awesome. Oh, this is absolutely amazing. We are technology experts. Why do you ask? All right, let me pull up the PowerPoint and I'll check out the chat. Looks like we have a few chat things. Ooh, CF calls for papers. Excellent. Yes, we can always use more call for papers. Let me bring up my PowerPoint. And I am so afraid if I go into like presenter mode, it's going to do some weird things since it sees me connected to another monitor, but we'll see what happens. Let's see if we go to share screen. Screen share. Okay, cool. So I'm going to try to present, which I can't even see. View, oh, slideshow from beginning. Come on. Oh, it's working. Okay. Oh, wow, that's cool. I was not expecting that. I love it when things work. All right. So where did this talk come from? So some people got the Flipper Zero. I don't know if everyone is familiar with what this is, but it was a small little project to build the sort of Tamagotchi RF hacking device. And people got the Flipper Zero and they're like, this is cool. What can I do with it? And so I previously was working at NASA, and now I am working at Amazon doing device work. And one of my big fields of study is RF technology, which is exactly what the Flipper Zero is doing. So what I'm hoping to do is give people an understanding of the capabilities of the Flipper and what the different functions it provides are doing at a very fundamental level, as well as give some practical examples. So this talk is going to be largely sort of like a science lecture. I would rather do like a CTF, but because I would have to give everyone all this equipment, that's not going to happen. So let's see. So once again, my name is Kaitlyn Hamilton, and I'm glad to be here. And we're going to start off by looking at the infrared sensor, which is, you can see it on the camera, which is this big black square thing here. And you may have seen this on like remote controls and stuff before. And we're going to do a bit of a deep dive into what's going on here. This is actually kind of interesting. So infrared light is light that that's just before visible spectrum. So if you look at the spectrum of like the rainbow, you'll see at the lower end, lower wavelength of visible light, you have red, and that goes all the way up to our friend Roy G. Biv. But below the visible spectrum, there's something called infrared, or like below red. And that's where these transmitters come in. They're basically shooting light in that spectrum. And if we look at a simple infrared transmitter that you would hook up to like an Arduino or something, it's very simple, ridiculously simple. 3 pins, one's power, one's ground, one's data. It blinks an LED on and off. That's all it does. And then if you look at the receiver, it almost looks deceptively just as simple, but we're going to find out in a second it's not actually. So you have the same 3 pins. So what you send to one device, you sort of read back on the other, but you have this like black sort of, I'm going to say transistor looking thing here called the IR receiver. And if we go and look around for this part, we see that it is an IR receiver diode, has 3 legs, looks a lot like a transistor. Now, most diodes have 2 legs. This has 3. What's going on? I went to the data sheet and it was actually kind of interesting. So I initially thought this would just be like a light sensor, like a photodiode, but it's not. And unfortunately, Zoom is kind of covering things up here. But if you look at the diagram here, you can see that there's actual signal processing going on. So what happens is that you get the infrared light going in, actually has a control circuit, which I'm pretty sure is doing a phase lock loop of some kind. The AGC is automatic gain control, which is oftentimes employed right before a radio does some sort of AM amplitude modulation decoding. And then, yeah, it demodulates the AM signal and then sends it back through a transistor, essentially, which, blinks the data signal. So it's not just, it sees lights, therefore it turns on. There's actually data processing going on in these modules. And I have some of these modules set up to go. So, right, so yeah, so this module, the RF frequency, is running at about 38 kilohertz. That's usually what we see on these IR remotes, about 38 kilohertz. Although you can find IR transceivers and receivers running on a few other different frequencies like 30, 40, 56, but never that high, which is weird, right? Because usually we think higher wavelengths, we think really fast data speeds. Like for example, 5 gigahertz Wi-Fi is faster than 2.4 for various reasons. But with IR, it's just such an old technology and it's basically like Morse code that all this stuff's really slow. And it's just like off and on, like it's literally like almost the exact same thing, like fast Morse code. Oh, so here's a fun thing. Does anyone have their camera with them? Okay, so I use I need someone to come up with their phone. That's fine. I'm almost actually the cheaper the better. So it turns out that if the back side of a camera, if you look at like the back side of a camera, and this is an iPhone, so this is they really pride themselves on their cameras. They have these nice lenses and whatever. But the front-facing camera, anything fast. And it turns out that the IR, the front-facing cameras, will pick up the IR lights from the sensors that you use. So let's do it. You put on your front-facing camera. Red. Right, front-facing camera. Let's see. Here. Okay. Working?
It's not the flipper, not the actual.
Yeah, I agree. Let me see if I can
shut it down.
Yeah, let me see if I can shut that down.
That's turn around. We can see the screen, right? Turn around so we can see the screen. Yeah. And now we shine the flipper, we can see the light, right?
Right. So if we bring that screen here.
It's
Okay,
not working. No?
Oh, also the angle as well, so.
Oh, there we go. Here, that one. There we go. Okay, so. There we go. Do you see the lights coming on?
Oh, yeah.
Yeah, you can totally see it in the front-facing camera because they go right? Yeah, it looks like a flicker.
Yeah. Just a little bit.
Yeah, there we go.
Oh, yeah.
No, well, not because.
Yeah.
Oh, that's so much.
Oh, I agree.
Yeah, any good camera. Oh my God, so good cameras should not go through this because they're going to filter out the IR.
Okay.
I don't know how much you pay for this, so it's expensive, but whatever you pay too much.
Okay, let's,
Oh, go on.
so apparently they're having issues with the audio, so I guess I'll have to turn on the.
It's because my microphone is coming out from my from here.
Oh, okay, so actually, yeah, let's change that to.
Yeah.
This one, right?
Yeah.
That's it.
Hopefully people can hear me better now.
Can you?
Yeah, don't worry. Yes, we are. I assure you, we are technology professionals. We know what we're doing. Yes.
So it's a good trick to check it for remote, TV remote works well.
Yes. So you can use this on any TV remote, any IR remote. You turn your front-facing camera or any cheap camera. Like I said, this will not work on a good camera, but on a cheap camera where they don't filter the IR, and when it comes into a sensor, you can actually see the lights turning on and off, and it comes in like kind of magenta, which you know is a problem. So anyway, so
Wait, why do you pick the front camera? Because he tried the back camera works too.
Oh, well, that's probably because the back camera, it shouldn't work. So you usually, when you have a back camera, there's, lenses and coatings, and it's supposed to block infrared light. So
Why is that?
You get a better image.
Okay.
The sensors can't distinguish between, infrared and other types of lights that we can see, but of course we as humans do. So we as humans normally would not see anything in infrared. So a good camera is going to filter that out, or a good lens will. But if you don't have those lenses, you're using a cheap, camera, and usually front-facing cameras are better for this because they're cheaper. You'll be able to see the light from the infrared remote. Okay, so cool. So we saw that. That was awesome. Am I still sharing my screen? I am. So yeah. So when you send data from the IR, like your IR remote, you're only sending a few bytes. Literally, like sometimes it's just 4 bytes, and that's it. And you need, of course, line of sight. IR is just like regular light. It'll bounce off walls. It won't go through anything. And of course, remotes have been around forever. So you expect there to be like a standardization and everything. No, of course not. Every company has their own standards that they use and employ. And if you've ever bought a universal remote control, you know how frustrating this is. We could have the universal like IR standards, but we don't. So you have like NEC, you have Sony, you have Sharp, Panasonic, all doing their own thing. Why? I don't know. But the most common you'll find in most electronics is NEC. That's the Nippon Electric Company. They made the TurboGrafx 16. And essentially all it does is it sends out 2 bytes of an address and then 1 byte for a command. So if you've ever used like the Commodore 64, and you just like poke an address, that's essentially all it's doing. It says, here's an address, here's a value, boom, that's the command. Okay, so I made my own little IR remote. We can take a look at here. And we're going to use the flipper to decode it. So I need another volunteer to come up.
Oh, camera here, so.
Perfect. So, okay, so we have a receiver here, and this is just essentially a light bulb that's going to turn on. And oh my goodness, this is a mess. By the way, I love these Velcro ties. They are amazing. Don't let my current situation deter you from getting Velcro ties for all your cables. I just need to detangle these. There we go. Okay. So like I said, this is a receiver, and there's the little IR receiver that we saw earlier connected to it. And when it receives the right commands, it will turn on the light bulb. There we go. And now we have on this breadboard a remote control with a single button. If I push the button, the light will come on, hopefully. If I did not completely bork this up on the way here. Oh, there we go, turned on. I will push the button. Oh, and the light turns on, perfect. So I need a volunteer to decode this. Does anyone want to come up? Do some IR hacking? Kaz, come on up.
Sure. Do I need to get up there? or-
Yeah, yes, please.
Okay.
You gotta come up and you gotta like introduce yourself.
All right. Hi, my name is Kaz. I work with Kaitlyn at Amazon.
Yeah. So what I want you to do is, so there's a function here called learn new remote. Can
Okay.
push the center button.
The learn new remote button.
Yep.
Cool.
Now we're going to learn this remote. So we're going to point it at the IR receiver
Okay.
and then push the button.
Move it down a little bit.
Okay.
There you go.
Oh,
Oh, and what does it say? What does it say, Cass?
it says A1337 C9B64.
Right. And so we got it. That's the address. That's the address is 1337, obviously elite. And then the command is 64. So why don't you repeat it at the at this IR receiver?
Okay.
Turn on the light. There it worked.
Oh, yeah.
Yeah, so we not only decoded. Yeah.
That's how you have
So,
all the processor.
Yes.
So it learns the address, not the frequency.
So the frequency of the IR is always the same, pretty much. IR is IR. So this is almost like visible light. Like I said, it's using an LED to transmit. It's not using an antenna. It's just blinking an LED. We'll get into antennas in a little bit.
No, I mean,
Yeah.
learning the IR of that device.
Right.
That button, because remember you mentioned that each company has their own proprietary standard.
Mhm.
So that other one, not your device. but
Right.
The other device.
So the flipper will read the IR, and if it's a common standard like NEC or Panasonic,
Okay,
it will decode it. In this case, I was using NEC,
okay.
address 1337.
Oh, it decodes it and it learns that.
Right, exactly. And then it can replay it. So I have an actual IR device here. Let's see, where can we plug this in? Oh, that is not Apple. We'll just unplug these, plug it into the power supply here. Okay, cool. We got lights and everything. Awesome.
Bluetooth mode.
It's righteous mode. I don't even know what that means, but it's awesome. Okay, so now this is running. There's a remote here as well. It runs IR. Does anyone want to try hacking this device? Anybody? Yeah, come on up.
Hi, Alex.
Get it back here, exit. All right, you're gonna push learn new remote.
Okay, so on the camera.
Yeah,
Let's do.
yeah, you're good. Learn new remote,
Mhm.
push the center button.
This one.
Yeah, there you go. Now push the on off, this one, the top button.
Oh, it's true.
There you go.
Okay,
All right, and then,
000
Uh-huh.
and C045.
yep, so 45 is the command, address is 00.
Mhm.
Why don't you play it back at the
Bluetooth
device?
mode.
So what do you do?
The center button, send,
Center.
yep. So turn off again. There you go. And you can learn all the commands on the remote and then use the flipper
Nice.
to control any IR device. So this is a good
Mhm.
real world example of what you could use on a real device. Anyway, thank you so much. Yes,
Does it overwrite the last command? I
Uh,
mean,
yeah.
there's still a multiple decode.
yeah, let's go over this together. So,
So now can you make it work with the other one?
yeah, absolutely, absolutely. So we can, if we learn a new remote, we can, for example, record this button, and then we can save it. And we can give it a name, but because we're lazy, we're just gonna save. Oh.
Can you,
Oh, sorry.
Sorry. So now we can add a new function. And I'm going to turn off the lasers. So this is gonna be the laser turn off thing. Okay. So now we have two things in our remote and it's fully saved. So if I want to turn on the laser, I can select the laser turn on and the laser turns on or off. Or if I want to turn on the LEDs, LEDs turn on and off from the flipper. And you can save as many remotes as you want, as long as you have space. Yep. And like I said, it's basically Morse code. So awesome. Okay. Oh, perfect. Yes, we are technology professionals, people. All right. We know how to use computers. All right. Yeah, so we did the party lights. All right, now let's get into some real radio. So if you look at the flipper, you'll notice that there's a,
Actually,
oh, go on.
we have a question from
Oh, yes.
the audience. I don't know if you want to check it. It's on the chat.
Yeah, why don't I check the chat right now? Just joining, what would be your preferred method to capture the IR signal from a bound remote, from the bound remotes?
Well, it just means the special purpose remote. We already demonstrated it.
Yeah. So anytime you can just, get line of sight. And the other thing too is, so this setup here that I did with the, breadboard and the Arduino, I mean, I have full control over the remote controls. So if I want to do a deep dive into an IR system, this is what I would use. The flipper is really good for like the very simple stuff, the standard stuff you find. But if you wanted to like develop your own protocol, or if you were doing some really weird stuff, you'd probably want to just use a microcontroller. So. All right, so sub-gigahertz radio. What is this? Go away. Okay. No, back. Okay. Yes. Okay. So if you look on the Flipper Zero, there's a section called sub-gigahertz radio, and this is real radio. So we're getting into the real like antennas going through the air, that kind of stuff, AM, FM, decoding. So if you develop a device like a doorbell, we'll get into those in a little bit, or anything like a garage door opener, you can design your device to send out an RF signal, but only on certain frequencies. It just so happens that the Flipper Zero will listen on those frequencies and record those signals, maybe decode them, maybe not, but definitely do a replay attack. So in the US, frequencies are like 310 to 318 megahertz. Usually we see it around 433 megahertz, although sometimes we will see 915 or 925 megahertz. And most of these signals are just simple AM or FM transmissions. So yeah, let's boot up SDR here. So an SDR is a software-defined radio. That means that we are going to be looking at raw radio signals going into the computer. And I'm just going to set up this dipole here. By the way, yeah, so people can see. There we go. I'm just going to plug a little dipole into. Oh, okay. See. Oh, perfect. Thank you. Yeah, this is very complicated setup. So we're going to actually look at some of the radio waves coming off of a little device that you can buy from the store. So we're going to plug this in. This is an AirSpy, by the way. I highly recommend these. They're a little bit more expensive than the $20 SDRs, but they do a fantastic job. So there we go. There we go. I'll have to see if we can get this steady. Okay, cool. I think. All right, this is some heavy grade engineering right here. Exit. So we're gonna go back to the desktop. We're gonna open up SDR Sharp. By the way, the demo gods are not gonna like today. So expect bad things to happen. So we're gonna go to, go away. Zoom. We're gonna set the frequency to 433 megahertz. 3, 4, 3, 3. I'm gonna turn down the audio. And we're gonna switch to the AirSpy R2, perfect. Play. There we go. So what you're saying is around 433 megahertz and nothing's happening. This is just the noise floor in this room, which is actually really good. I wish I could do more radio stuff in here. So here's a doorbell, a wireless doorbell. And I'm just gonna ring the doorbell. There's no batteries in the doorbell itself. Oh, what's that? Ah, something just happened. Where was that? It's a little to the right, so it's a little higher frequency. So 433, let's try 492. Yeah, 433.92 megahertz. Something's happening. Let's take a listen. So it's in, I'll put into AM mode. This is going to be a little staticky. No, I don't actually hear anything. My audio is clearly off. No? Oh, well, if the audio works and the demo gods were not mad at me, we would actually hear some audio.
This is 434.
This is what?
434.
It's 433.92 megahertz. So what we're seeing here, so if we look at this, this is a spectrogram. So and actually this is a Fourier transform. So these are frequencies lower than 433.92. These are frequencies higher. And then we're seeing where the signal strength is right here. So we do see that there's a signal coming from the doorbell. Now, normally, if the doorbell had batteries, it would ding dong. Yeah, let's put some batteries in.
A scientific term.
Yeah.
Yeah, it would ding dong. Oh, and this might be a little loud. Try it again. Ready? Yep. All right, so let's hack the doorbell. Let me check the batteries again so we don't constantly ding ourselves. So one way you could do this is if we have the SDR, right? So we could go into something called the Universal Radio Hacker. I have this installed. Universal Radio Hacker is great if you're lazy like me and don't want to write your own DSPs for everything you decode. So we're just going to go and record a signal. We're going to record from the AirSpy R2. Oh, look at that. It's already set to 433.92 because it's such a common frequency for these devices. We'll just start recording. We'll record the signal. It's done, so we'll stop. We'll save it to the desktop. Let's see, desktop, that's good enough. Okay, save. Close out of this. And because this is awesome software, it's automatically going to load and try to decode the signal, which it already did. So actually we'll process this again. So there we go. So it's decoded all the ones and zeros that was sent out. In fact, we can look at the demodulated signal here. Zoom in. Sorry, can we make this bigger? It's not really, apparently. There we go. Okay. So there we go. So we'll see what's happening is that we're seeing the same signals. And if you're familiar with digital electronics, this is like very familiar. This is because it's using amplitude modulation. We're sending out these square waves, and from those square waves, from the infrared, from the 433 megahertz radio wave, we're getting data out. In fact, we can analyze it over here and view it in hex. And we could repeat this to ring the doorbell. However, the flipper actually is easier. So I need another volunteer. Who wants to come up?
What do I do?
Oh yeah, okay. You're gonna hold this.
Yes.
And we're gonna go in front of the camera here. And we're gonna go to sub-gigahertz. All right, and we're on read, okay? So I'm gonna push read, and then I want you to push the button. So okay, I'm push the button.
Release it?
No, keep pushing it. Now release. Try again. Release. There we go. It got it. So, okay, so hold on to this.
Sure.
Onto the flipper. I'm going to put the batteries back in. Push the center button.
This
Yep.
right here?
Uh-huh.
Release it?
Yeah, push and release. Quicker. Oh, let me see what's going on here. Oh, there we go. Sorry, I don't know why that was being weird. So push the right button,
The right arrow,
right arrow. Yep, percent.
release it.
Yep, really quickly. One more time. Oh, I think you pushed the wrong thing.
Oh, sorry.
That's okay. Right arrow, really quickly. Oh, why is that not? Oh, save. Sorry, push the center button really quickly. Oh,
Ooh.
center button really quickly. Oh, why is it not working?
Do it again.
Yep. Should be sending.
Or it has to be hard. Like,
I'll try one more time. So if this doesn't work, I'm going to teach people a little trick. We're going to go to read raw. I'm going to take out the battery. When I tell you to push the button,
the center button,
push the center button.
this one.
Yeah. Oh, right. Just push the center button and then let go. Oops. Try again. Oh, what's going on? Let me see. Oh, it's on send. Erase. Sorry about that. All right, push the center button, just let go.
It's picking up.
Yeah, it's picking up. Now push it again. Okay, so if we point it towards the camera, sorry, you'll see it got a signal at the beginning. Now we're going to push the center button again. So what we did right there was a very basic replay attack. It recorded the 433 megahertz signal, and it didn't even like do any recoding. It just recorded what it was seeing, and then replayed the WAV file back essentially. And we were able to get the doorbell to ring. And this is a great way to annoy your neighbors, by the way. If they have a wireless doorbell, you can record their signals on like a Hack RF or your Flipper Zero, and just 2 a.m. suddenly have neighbors rings of people that aren't there. So now, of course, if you're making a security device, you would use something like a rolling code and everything like that. I'm just kidding. So, so here we have a locking mechanism for like drawers or windows. And the way this works is you would attach this to like a wall or the inside of your desk, and it's just a magnet. And at the other side here, there's something called a read switch, which if it sees a magnet nearby, it closes the switch, and it can detect that the alarm is closed, or the door is closed, or the window is closed. So, and it has this 433.92 megahertz remote for locking and unlocking the device. So before, thanks, guys. So obviously what we got to do is we'll put in some sound. And by the way, this is going to get very loud. I hate this thing. This is very loud, but I'll show you how this is supposed to work. So if we have a, when the drawer is closed, we can then push the lock button. Push the lock button. Okay, it's that 3 beeps means it's locked. And if we were to move this away, it's going to be really loud and really annoying. All right, ready? 1, 2, 3. Okay. All right, so we need to hack this. We need to hack this so it doesn't do that anymore. So actually, we'll keep the batteries out for now. Do we have another volunteer? Yeah, come on up. So we're going to do the same thing again. Exit. And you're going to select read raw. Okay, and then you're going to push the record button. And then push it again. All right, now we have a recording of the disarm button. Okay, now let's try this again. We're going to arm the security device. Oops, I meant to do that. That was. Okay, we're going to lock it. Replay it. Replay the unlock. Now it's unlocked. Thank you. and by the way, there's no rolling codes. Normally, the way you would get around this is you would have like rolling codes on your devices. This, of course, being the finest security device from China. No matter how many times you lock it, you can just replay from the flipper, send, and it unlocks. So no rolling codes. That's awesome.
So the industrial one is much more sophisticated. They have rolling codes and others.
Right. So yeah. So this is an example of security gone bad by our fine friends at the Chinese $5 Chinese lock company. So but however, just because something has a rolling code doesn't mean you can't use the flipper to get around it. Yes.
How many frequencies can the flippers transmit?
Good question. So one, it depends where you are. So like I said, different countries, different areas have different frequencies that it can transmit on. However, the Flipper Zero specifically can only transmit on around 310, around 433 megahertz, and around 915 megahertz. That's it. So it doesn't have a full SDR. It has a little chip inside that does, device stuff. Yes.
So is that limitation only for transmitting, or can it also receive
Both.
different frequencies?
But so one lesson I really want people to take away here is that even though the flipper is like a really cool device, there is always something better for each individual task. So for 433 megahertz hacking, I highly recommend picking up one of these. This is a Hack RF. It will not only do the same sort of recording we did, it will play back. It will work on all frequencies between like 0 hertz and like 6 gigahertz. It does require, it's not the best SDR, to be honest, but it'll do all the frequencies. Unlike the Flipper Zero, which is specifically for these kind of devices. Yes.
How do you know which modulation you use? Like every time you're doing it, you're getting it off the person. How do you know which modulation to use every time?
All right, so the nice thing about a simple replay attack is you don't actually have to demodulate. So if we look back here at, we're going to go back to the camera. If we go back to the camera, what's happening is when we record a signal, we're going to go to read raw. We're going to record. Oops, I didn't realize the batteries are still in there. But all it's doing is it's picking up the raw radio waves and then playing it back. It doesn't matter if it's amplitude modulated, frequency modulated, or phase modulated. It doesn't even know what it picked up. It's just going to play back what it heard, essentially. If you actually want to decode it, usually on these kind of devices, it's always going to be either some sort of amplitude modulation or frequency modulation. Very simple. Once in a while, you'll come up with like phase modulation. That's very rare. For these types of devices, most digital devices you use will have phase modulation actually. But for these cheap devices, they're as cheap as possible. So if you go to like the Universal Radio Hacker once again, like I said, this tool is really great if you don't want to write your own DSPs, because what will happen if we open up what we recorded earlier. Let's see what it is. It was on the desktop. Desktop? No. It actually automatically, yes, actually, it will automatically try to decode the signal for you. So if you're really new, or if you're lazy like me and you don't want to go through the process of figuring out what exactly is going on, or go into like GNU radio and like do the processing. If you want the raw, like just bits and data, Universal Radio Hacker is a good first step for these kind of devices. And like I said, it will select automatically. So it says here, the modulation is AFK, or amplitude shift key. You also have frequency shift key and phase shift key. So that answer your question?
Are these free?
Yes. Universal Radio Hacker is completely free, open source. You can download it from GitHub. And it's on all operating systems. Okay, so let me pull back up the presentation. Okay. Oh yeah, so here's something that's really interesting. Yeah, so Tesla recently, it turned out that to open their charge port, they use 433.92 megahertz, and they didn't use rolling codes. So you can do the same thing to go into the charging port of any Tesla vehicle. So
We have a Tesla outside, though. We
Yeah,
can try,
we-
right?
yes, we can totally test that. We can totally test that after the presentation. We should totally go outside. Yes.
How do you know between like two different Teslas? Does it have?
It doesn't matter.
It's the same. It's the same. They're all the same.
So if there are two cars right next to each other.
So I was driving up the 880 to Oakland, and there was a truck full of brand new Teslas. I used my flipper on it, all of them open. It works.
Yeah, you just pointed the
That is amazing. I love that. Okay, we unlocked the system. All right, so here's the black magic, and here's the one I really wanted to talk about. So, okay, so RFID. If anyone's ever seen RFID, it is black magic. And I spent some time reverse engineering it, figuring out exactly how it works. And I'm gonna demystify the whole thing because it's really stupidly simple, but it just seems like magic because you have a card and it has like no power source. You put it up to a like reader and just through the air, it magically like sends data out and it's like, what's going on? So
we have a Tesla outside, actually.
oh, yeah. So we could either do it now or after the presentation.
Let me join the meeting with my phone, and we can.
Do you want to do it right now?
Yeah.
Do you have a flipper set up for it right now?
Max has it.
Okay, let's do it. Let's do it. Let's do it. Let's do it.
So right there.
He's gonna have to join me to.
Before we,
Yeah.
let me log in first.
Okay. Oh, okay. Intermission time. Intermission while we get ready for the Tesla. No, I like it when things sort of naturally progress.
So it's gonna be either that one or the one under.
So you're the one controlling your remote.
Duh, I control my own flipper.
I was wondering why this was changed. All right. So wait, the top or the bottom one?
It's one or the other. So different Teslas use different signals,
Okay,
but most of them respond to one or the other.
we'll just try both.
Yeah,
And where did you get that signal in the first place to put in there?
it's on. I think the fifth.
It's also on GitHub.
Yeah.
Yeah, it's all, you know.
There's a really nice library on GitHub where with all the IR commands. You
Yeah.
can just download to your flipper.
Yeah, oh, and there's that. There's also, when I made that, I used the Arduino IR remote library, and you can basically copy any remote on the market. So like any protocol, anything you can do just with an Arduino and those little stupid IR receivers. By the way, once again, Chinese manufacturing and its finest, if I can find it. Here we go. So I got these receivers, came in a pack of 6. Can anyone see what's wrong with this one? I don't know if anyone can see clearly. Anyway, they put on the component backwards. So like 4 components. They had one job and it's on backwards. So
Quality control.
yeah, I know, excellent quality control right there. So are we still planning on going out and
Yeah, we're ready.
ready? Let's go.
We're on set too, so.
All right. Go hack some Teslas. This is awesome.
Okay, can you?
We're here at Hacker Digital and we're about to get my Tesla hacked. All right, so Flipper Zero is going to hack the charge port.
Okay, okay, can you check if the video is showing on the screen over there?
Where is the,
It's not showing yet.
where's the transport?
Yeah.
On the other side?
No, it's right here. Oh. Where is the?
All right.
Hold on, so just
Okay, I've got a. I've got a message primed and ready to fire.
Hold on. Just waiting for his call.
Actually, don't worry, it's gonna be
So whose flipper are we using? Oh, yours?
Okay, hold on.
Urban switch.
Okay.
I'll see you now, Marco.
Whose car?
That's fine.
Hold on.
That's yours?
I've never seen this color.
Oh, it's a vinyl wrap. It protects the paint job.
Oh.
Marco, we can see you.
Okay, you can line this up.
Hold on. And how do I know.
That's
And how do I? All right, I think I'm just gonna do this. All right, so.
Yeah, I can see it.
All right, cool.
Oh, that's Ed's car.
No.
Oh,
Wow. With the flipper, huh? Yeah, with the flipper. That's a little dark.
oh, there's Eddie right there.
What's the consequence of when the cabinet?
Wow, flipper zero. Yeah. Can I close it too? Easy as clicking a button.
You know what I do want to know is what does the driver see when that happens?
That's rude.
If anything,
Sorry. Oh, like as if I'm in the car?
right? If you're in the car, does the car tell you anything? Because you're not near a port,
Let's see.
but the door open.
Okay, we'll check it out real quick. We'll close it and then send it again. Okay.
Because I can't believe that this is that dumb that anybody can open it and you get no alert.
Right. Well, I can't. Are you ready? Yeah, ready. Uh-oh. Oh, wow. My whole portal, it thinks I'm ready to charge.
Okay.
Wow. That's pretty good. Elon, we need to work on this. On rolling codes. Setting it.
The question is, can you discharge it? Plug something in and take the,
Well, can we steal the power?
yeah, that would be. Emergency,
All right.
it's pretty cool. Find some Tesla, right?
Go ahead, guys.
Final.
Go ahead.
Yeah, see what's over there.
All right, so this is how we roll. So you missed this. Too bad.
Yeah.
That's true.
I mean, it's dramatic.
Try it after you're done with your presentation.
Yeah, I would probably done get
Gives you a screen and.
There is coffee over there. You guys want? There is coffee. Otherwise,
Oh, yeah.
we can roll.
All right.
I got it from him.
Right, but it's in blue, not in white.
Oh, yeah, I don't know. Yeah, there's two of them.
I like the blue.
Kaitlyn, I turned off your sharing screen and camera
Okay,
so that we can just focus on.
Oh, okay.
that's fine. Did you put malware on my system?
Obviously.
Okay, excellent. Should be pretty good.
To answer Shannon's question, would it open if the car was in motion? So far, I haven't seen it open when the car's in motion.
That is definitely something we can test.
All right, Eddie. I'm really used to that. We can try it right now.
I love it. I love it that people brought their own devices for us to hack. That's so nice of you. Okay, so RFID. So this is the black magic stuff. This is the stuff that like, how the hell does this work? You have a card, it's not powered, you hold it in a reader, somehow like magically data gets off it and you're let in. Okay, what's going on? And actually, before I change slides, I do want to point out that if you look at these cards really closely, there's some numbers here. If you're ever given a RFID card and there are numbers, write those down. Those are usually the codes to get into the building. Just right there for you to take.
Oh, actually, can we try the access controls here?
Oh, we absolutely could at a bit.
Okay.
Not every access control is necessarily vulnerable, but we can take a look.
Yeah. So it shows the camera.
So it's my camera, let's see. It's the Nexi Go.
Maybe test.
Okay, my.
That's okay, it's not quite as neat.
I think it's the spotlight.
Oh, hold on.
No, it's not that. Yeah, that's fine, Kaitlyn.
I see the camera.
There you go.
Still be sharing screen.
Another quick question, is this similar to like the push to start cards too as well?
Push to start should have rolling codes. The push to start, I believe, uses long range RFID. Although I could be wrong, I haven't looked too deeply into it. There are types of RFID that will work over longer range if the transmitter is powered. However, we're just going to be looking at the unpowered types where you just push, put your card over the reader and then something magically stuff appears. Okay, so like I said, if you see numbers on the card, write those down. Those are important. Yes,
There's one question in the chat.
in the chat. let me-
What was the hardware device you were using earlier to show the spectrum as the SDR again, please?
Oh, yes, I'll show that. So I was using a AirSpy. So this is one of my favorite SDRs. It's receive only. And it basically has the same frequency range as like those cheap RTL SDRs, but I find it does a very good job of reducing noise. And also you can get a little adapter in the back. And if you have a 10 megahertz lab clock, you can, like a atomic clock, you can hook it up to the back here and get spot on signal reception. So you don't have to worry about signal drift. So this is the AirSpy R2, fantastic SDR for UHF, VHF. And LBAN. All right, so let's continue. All right, so what's going on? How does RFID work? Okay, so I need to move this out of the way so you can see how this works. Okay, so if you have an RFID reader, we're looking at the 125 kilohertz type, which is the low frequency RFID, which I believe are these. Yes. So you would have a reader and you would put like a key or a fob on top and it would read it. And the way it works is that you have inside a little transmitter and it's always transmitting at 125 kilohertz. Connected to the transmitter is a little receiver filter thingy. Basically what it's doing is that it's looking at the envelope of the power usage. So when there's something nearby, it's going to draw a little bit of power from the antenna, and that's going to change the shape of the sine wave slightly. And that's how it's getting back the data. And let's take a really quick look at how the RFID card or reader works. So this is what a typical dipole antenna looks like. Normally, this would actually be in a circle or like in a rectangle, but for simplicity's sake, we're just having a very simple dipole. And it receives this 125 kilohertz signal. That powers the device. That's all it needs. Because it's getting like one or two volts nearby when it's like right on top of the transmitter. That's enough to power it up. There's some data and logic inside, usually some code. And that's going to turn on and off a resistor. That resistor is going to bridge both sides of the transmitter. And every antenna can both receive and transmit. So what happens is it gets a 125 kilohertz signal. It sorts the antenna with the transistor, and you get the same signal coming in, causing it to emanate, causing what's called backscattering. And that's how it's able to power itself. So this uses the signal that comes in and it emanates the same thing away. I'm going to do that. And so we can take a look inside. This is what's inside here. So I took this apart, did a lot of analysis. So up here is where the input comes in. So it reads from this antenna and transmits, sends the signal through this. It goes through these diodes. It goes into this tank circuit up here and goes into this chip. This chip basically handles everything. It's like it's a single chip solution, and then the data goes out to the USB. And of course, there's a signal going out to this antenna. And if we look at the signal coming out of the antenna, it's exactly 125 kilohertz, and it's 23.6 volts. So it's a good amount of power going through it. RMS 8.3 volts. So don't worry about RMS actually. And if we look inside like a little key fob, you'll see exactly what I was talking about, where you have two leads going into the little chip here, this little black gooey chip, super cheap 1 cent chip. And then this is the antenna around it, essentially acting as the dipole. That's another up close picture where you can more clearly see the leads from the antennas coming in to that. And like I said, inside there's just a little transistor that will short the two leads together, which is how you get the backscatter. Anyway, let's see what's going on with one of these RFID readers. Let me grab a. I have the cable man. So what this does is this works on very specific types of RFID cards or readers. And then we'll act as like a keyboard. There we go, plug it in. All right, now it's ready to go. And now I'm going to need, where did I put it? Here it is. Okay, so this is another SDR. We're obviously working a lot with radio. So we're using a lot of software-defined radios. This is called an AirSpy HF. This will let us receive signals as low as 135 kilohertz. And attached to it is an RF probe. Now, these are highly technical devices. You usually get them in entire packs. And what you would usually use these for is that if you have, let's say, a circuit and you're submitting it to the FCC, and you want to find out if like a certain trace is giving off too much electromagnetic radiation, you can run the probe along the trace and view all the RF spectrum. And of course, these are highly specialized devices. You could, if you go onto Amazon, it's going to cost you all of like $8 to get a whole box of these. So, so definitely worth your time. Or you can just make your own if you have some spare copper. Yes.
What is it called?
RF probe. Yeah, radio frequency probe. So I have one of those probes attached to my AirSpy HF. Essentially what I'm doing is I'm turning my SDR into a spectrum analyzer. And we're going to view the radio waves coming off of this reader. So I'm going to plug this back in.
So the traceability test is for compliance?
Yes. So when you submit to the FCC, and if you ever seen a product that says like this is FCC approved, they've done this. They've taken these probes, they've gone throughout the device, and they've tried to figure it out where it's emitting a lot of RF spectrum. So we'll open up SDR Sharp again. SDR Sharp. Okay. We are running the AirSpy HF. Let me set that down there. We're going to turn off the audio. We're going to set this to 135 kilohertz. So that's 0135. All right, can I get a volunteer? Who wants to come up and probe RF? We need a prober. Okay, thank you.
The closest one.
Okay, so just hold that there. All right, I'm going to start the HF. There we go. All right, now move the probe close to this. And let's see what happens. Oh, there we go. You see that on the screen?
Ooh, awesome.
Yeah.
It's like heat map. huh?
Yeah, it's like a heat map. So we see around 125 kilohertz. There's a signal. Yeah, you can take a look for yourself. And if you get it really close, you can see exactly the signals that are coming out. And most of those, so what you're seeing here is there's a main signal around 125, 135 kilohertz. And then there are these sort of transient spikes because it's really hard to get a perfect sine wave. But you can always identify, oh, this is the big one right here. And then if we were to do the math, we'd find this is like a perfect multiple, or something. And that's what we're seeing on these. So we can definitely see the RF going out. Now, here's the magic. 1 second. I'm going to give you something. So this is a key fob, 125 or 135 kilohertz key fob. Yeah, it goes right through paper.
Material testing.
Okay, so what I want you to do is I want you to hold the key fob on the other side of the probe, so on the top side of the probe, and move it towards the reader again. Let's see what happens. Oh, no, get it really close. Get it really close. No, you can touch.
Got a much more
Yeah.
complicated structure.
Whoa, what's going on? That's the backscatter. So when you have the, when you have the key fob near the reader, it's just going wild. It is sending out all this backscatter. And I did not find anything online about how to decode this. However, I figured it out. It took me like a day. And we'll do that again.
It works either side.
Yeah, it works either side, yeah. Oh, well, she's having too much fun. I don't know. I know, but isn't that cool? You can see what's going on. And this is what I really wanted to show everyone, because it really takes the mystery out of how these RFID readers work, is that it's taking that sensor signal and then it's basically reflecting it back. And it's so dumb and so ridiculous. It just backscatters all over the place. But it is modulated and we can get data off of the device.
So will that work with a credit card?
That is NFC, and yes. So this is specifically 135 kilohertz low frequency RFID. And so that's only for like little tags. Like you would put this like if you were maintaining a warehouse and you just wanted like tags on everything. And you
Does
just,
it do those Apple tags?
I don't know what, Apple tags are like for tracking, right? That's
Yeah.
different. So RFID is normally like if you're in like a storage system, and you have to keep track of like 1,000 different products, you can just scan them and then, yeah, they're very simple. We'll get into NFCs in a little bit, but it's the same principle.
I have a question.
Yes,
Can we block that with a sheet of metal?
let's try it.
Sheet of metal?
I will, I'll put my phone in the way. That's a sheet of metal. You still see something. What if we put this on top? Yeah. It blocks most of it.
But this is a lot of layers.
Yeah.
How about slim it down a bit?
Slim it down. Let's
Yeah,
see.
because
What do we
that's
have
a-
this?
Needs a tinfoil.
Yeah, we need tinfoil. We could try using. Yeah. We could try using this cord.
I just need 1 centimeter.
Yeah, no, it's blocking it.
1 centimeter.
If we go like on this side over here. Yeah, no, it's blocking it.
Nice.
Is that
So,
something?
because
Yeah.
this is such low.
Yeah.
frequency.
Yes.
What is this?
RFID blocker.
Oh, RFID blocker, here you go.
Okay. Oh, here you go.
Okay.
Let's try the RFID blocker.
Doesn't work.
Where did you find this?
Free one, so.
Well, actually.
Oh, really? Well,
Well, you got your
now
money's worth.
we know. Now we know, right?
Yeah.
We don't buy these things.
Yeah, exactly.
It's a scam.
Whoa.
Okay, how about devices.
backstab, that's
But,
what
I
you
won't be
Yeah.
satisfied. Oh, you know what? I won't be satisfied
Oh, you
until
will?
I
Oh.
do it.
You really want to have a tinfoil hat on.
Yeah. No, yeah, it's even inside, yeah.
We have an RFID
Yes.
wallet.
RFID wallet, let's try this one. So keep in mind, this is for low frequencies. It might work better on NFC devices.
Oh, with all these credit card, are you sure?
Yeah, that's, I guess.
Oh, you got it to me.
Oh, no, it's coming through. We're getting some signals now.
Oh.
Wow. Oh, but they expect people would not use it this close. Somebody would have to like, you know,
Well.
rub it on your wallet.
So there are like giants, like RFID, like transmitters, receivers that you can use to get stuff at a slightly larger distance. But these are unpowered, so you have to do that.
So those,
Yeah, they still have to be pretty close to.
okay, so yeah. Yeah, you have to be this close to you.
That could be done.
My credit card wasn't there.
So they buy like a garage door reader for the cards, and the garage door readers are
Yes.
designed to work at like 2 feet away, and then they will
Yeah,
press
we'll
those,
do that in a second.
which is pretty
Oh,
cool.
okay.
So they can get pretty far.
I see.
All right, sorry, we're having so much fun here, but we really do need to go.
Okay,
sorry.
are we
Anyway,
ready?
yeah, yes. All right, good job. Thank you.
I'll take the wallet.
Thank you.
Thank you. Okay, so that took a little bit longer than expected.
Yeah, you're closest.
Yeah.
So.
So what I did to decode it is I found out. I added some leads to this, and I was able to get into the decoding circuit. And I found that what it was doing is, I thought initially it was just reflecting back on the main signal. That's not what it's doing. It's looking entirely at the backscatter. So what you want to actually do is we're going to stop recording or stop playing back. We're going to set the sample rate to something really low, like 32 kps. Okay. There we go. We're going to set the set it to like 9 kilohertz. Can't see. Yeah. Well, that looks, actually, let's go to the center one right here. There we go. We're going to set to raw IQ. We're going to center it. There we go. Okay. And then we will record. Let's see how we record. Record theme. Ah, there it is.
There.
No, frequency manager. No.
And 3 bars at the top left on the option.
Here?
I think so.
Yeah, it should be a record.
Oh, I think we got one more than
Yeah. Oh, anyway, so the signal's right there. If you put into let's see, how would we record this? There is a way.
audio, maybe.
No, we don't want to record the audio. We want to record the IQ. So we have IF, not IF recorder, IQ recorder, DSD, band plan, audio recorder, and yeah, no, where is it? This is obnoxious. Okay, the gods of demos have gotten this finally. AF, Zoom, audio, baseband.
Yeah, that's perfect.
There we go, stop. And it crashed. Okay, perfect. All right, but yeah, what you do is you record off the sideband, you load it up into Universal Radio Hacker, and you can get the data off, or you can do something even simpler. go to the flipper. Exit 125 kilohertz RFID. We will then read. We will read. We will read. There we go. Okay. And it says here that it is, you know, a card, and we can use it to play back the what's on here onto that. Anyway, let's continue. Okay, and so yeah, we got the backscatter. So yeah, when you're dealing with these low frequency RFID cards, you're usually going to come up with HID prox cards, which is the most common type, or EM4100s, which are often found in like Eastern Europe. I've never seen them here in North America, but they're just all unencrypted. And usually it's written on the cards. Remember I said if you see a card and it has numbers on it, those numbers can probably be, are probably what's being read off the RFID reader. So HID prox cards are really awesome. They only store a few bytes. It's usually the facility code and the serial sequence. So for example, at my apartment complex, the facility code is always the same. And the sequence number goes up by 1 for every resident. So when I moved in, I read the RFID from my key fob. And then I was locked out of like stuff because it was COVID, but I wanted to check it out. So I just increased this, decreased the sequence number since I was the newest one in. And I just, found one that belonged to like a manager or something, and I just got into all this stuff.
A low number, right?
Yeah, it was a lower number, just by a few. It was only like 50 lower than mine. And it's only like a 16-bit number or something. I mean, it's really, really insecure. And the fact that this is a new building using it, I was like, absolutely shocked. Let's see, we have something in the chat. The reader reminds me of a Pi Zero. Yeah, it's not even a Pi Zero. It is cheaper than that, I can assure you. All right, so and yeah, so the EM4100 stores 64 bits of data. That's it. And the problem with that though is that there's checksums at the end, check bits, CRC bits, whatever. That makes it difficult to read in like a hex integer. So I don't like those. And I would be remiss not to mention the T577 cards, which you can write to. So if you do see a key fob and you're like, hey, I want to let someone into my building, I can copy the RFID, give it to Sam, he can come into my building in 18 minutes.
So that's what the blue thing.
Yes.
Okay, cool.
And NFC is the same thing, except that it is, of course, at a much higher frequency. So NFC communication, which is another aspect of the Flipper Zero, is two-way. So what we saw earlier was that you put up a low frequency RFID tag near the reader, and it just reads from the low frequency tag. With RFID, you get like a two-way communication going, which is how you're able to do like payment processing and stuff like that. It can store more information. And when I say more, that's a very relative term. We're talking like some of them hold like 100 bytes, some almost 500. I mean, like sometimes even 900 bytes. I mean, we're talking big time here. And of course, it operates on the HF band, 13.56 megahertz. And most important to us is that it supports encryption, which is the bane of our existence, which I have to say, this is where the Flipper Zero sort of fails, is because so many of these things support encryption that the Flipper Zero just can't handle it. And so once again, this is what it looks like. You have a 13.56 megahertz signal this time, but then you read off of the lower like 12.712 or 14.48 megahertz coming from the chip or the key fob or whatever you're reading, your phone, whatever. And this should look familiar. This is what's inside a NFC reader. You got a big antenna built into the PCB, single chip solution, same tank circuit you saw before. It's the exact same thing. It's just a different frequency. And of course, NFC key fobs, same thing. The wires are slightly thicker. It's about the only difference. Still have the leads going out. And it just, like I said, acts like a transistor. shorts to 2 wires, and then it sends off backscatter. And let's see, does anyone want to see what it looks like on 13 megahertz? Let's do that real quickly. Since we can. Okay, here we go. See reader. We'll quickly open up the SDR.net again. We'll go up to 13.56 megahertz. It won't crash. So once again, we're going to set this to 13. .56 megahertz. 6 megahertz. Center frequency. There we go. Set this to the AirSpy HF. Run it. Oh, there we go. And we should see some stuff come up. Oh, there we go.
So that's just the reader.
Yeah, that's just the reader. So yeah, the frequency change. Thank you very much. 13. What was it? 13.56. And in fact, we can actually see the signal all the way over here. But yeah, it's pretty loud. This is actually much louder than the low frequency, but we also read from a much further away frequency. So if we saw earlier, we're going to read at 12.712 megahertz. So I'm going to get out a little RFID tag. So if we do this again, it's going to read it constantly. Thank you. Not much happens between it being here and it not being here. But if we go back to 12 point, this is exactly right, 12.712, 2, we should see the data from the NFC. Why is that 0? That's not good. Oh, because it read in the number and it read my so it reads in a number and acts as a keyboard. So let's see, this is 12. Yeah. 7, 1, 2. We'll open a notepad. There. Now we should see what's going on. So we do see a signal there. We take it away, the signal goes away. There's the signal. And that's what we're reading when we're reading the NFC, is that little bit there. So it transmits, it sends the power on one frequency and then listens to the backscatter once again on a lower or higher frequency. And if we were to record that, put that into Universal Radio Hacker, we could get the data out. Already spent enough time. So let's do something more fun. So there's common NFC formats you're going to come across a lot. The most common is MyFair. That does support encryption and it's used a lot in like getting into hotel rooms.
That's BART.
And BART, yeah. As well as many transit systems. And NTAG, which is essentially the NFC version of RFID tags. Anyway, let's go hack Nintendo. Because Nintendos, of course, famously use amiibos. Yes, so Nintendos have these little like toys to life things going on. And they're called amiibos. And basically what it does is that there's these little figurines and underneath the figurine is a little NTAG NFC sticker essentially. And it contains data but it's encrypted. Like I said, that's the thing about NFCs, is that, or the NFC format, is that a lot of stuff's encrypted. However, a few years ago, some hackers, much better than me, got into the Nintendo 3DS and totally stole the keys. They were just right there on like every ROM that they were sending out that used amiibos. So now the keys are out there and we can totally just like make any amiibo we want. But unfortunately, we cannot use the Flipper Zero. Flipper Zero is not powerful enough for this. So what we're going to use instead is something called the Proxmark, which many of you may have seen before. So this is the Proxmark right here. And all right, let's pull up a VM here. So we're going to close out of this. Okay, thank you very much. Oh, and by the way, you can see the numbers that it wrote when it read the tag. So hopefully when you do a security system, you're not using unencrypted RFID tags. All right, so we're going to open up the VMware workstation. There we go. We're going to plug in the Proxmark. Make it full screen. You can see what's going on. And so I tested this right before I left to make sure that the demo gods would not get me on this one, because this one I think is a lot of fun. So we're going to plug in the Proxmark, and it should connect to the virtual machine. Okay, awesome. PM3. By the way, so what I did beforehand is I downloaded from GitHub the Proxmark 3 software. Whenever you use the Proxmark, download from GitHub, don't use whatever nonsense that comes with your distro. You'll save a lot of time. There's a lot of stuff that you can only get off the GitHub, including the amiibo hacking stuff. So we're going to go into the Proxmark 3. Okay, awesome, it works. So we're going to pick I have Smash Brothers ready to go. So we need a Smash Brothers amiibo to test on. So I'm going to go into my downloads folder, amiibo bins. By the way, in this bins file I downloaded, you can see where the key is that they were using. I'm not going to open it lest we get sanctioned by the copyright lords. But if we go into Super Smash Brothers, okay, we can pick a character. So I need a character that someone likes. Kaz, I know you play. What's your favorite Smash Brothers character?
Is Cloud on there?
Fighter, Pass 2. No.
Go with Lucina then.
Yeah. Okay. Oh no, it's here. Cloud.
Yeah.
Cloud Player 1. Here it is. Okay, we'll go with Cloud. We're going to copy that onto the desktop. I'm going to rename it something a little easier for us to work with. Tab. Get to the desktop. So what we have to do first is change cloud.bin into a format that the Proxmark will like. So if you go into the Proxmark directory, there's a tools directory. And what we're going to find is the PM3 me bin to email.pl. It's just a profile that we're going to use to convert the bin file that we downloaded into an email file. So we're going to run PM3. Okay. Me bin to EML, and we're just going to throw in the name of that bin file. Top cloud bin, and we're going to have the output set to desktop cloud EML. Does not look like a proper file format. Oh, that's not good. Let's try another bin file. We'll go with Lucina. It's J, K. There we go. This one works better. I can't believe something I randomly downloaded off the internet wasn't very good. Stop. There we go. Okay, so it generated an EML file. It's on the desktop. And if you look at the bottom, it gave us the commands to run. Ooh, just right in Proxmark. So we are going to run HF, myfair, U, I forget what that stands for, eload -f, and the file that we just created. So copy all this.
My fair ultralight.
Copying is hard. There we go. Okay. There we go. It's done. Okay. Oh, actually, that's not done. We need to set the email. There we go. Now it's done. And we're just going to copy this command. And this is just setting the universal ID that we're going to use for emulating. Now, Cass, come on up. Let's get your Lucina.
Okay.
Oh, where's my switch?
Right there. Like to the box, on the table.
Oh, there it is. Thank you. So like I said, NFCs are encrypted, but if you have the keys, anything is possible. Here, go into the Amiibo section.
Okay, you want to show the camera?
Yeah. Well, I don't know how this is going to work because it can only go so far.
Still loading.
Still loading. Excellent. You know, I thought this would like go away. Oh, there we go. Yeah. I thought as soon as we got away from like CDs and stuff, we wouldn't have to deal with loading. Oh, I was so silly.
Symbol, right?
No, it's in some more Amiibo. All right, let's get your Amiibo. You're just gonna hold this right here. There we go. You got your Amiibo. Push A. Yeah, name the Lucino that we just created.
I don't know if
Can
you
you
can show the screen. Here you go. Oh.
No, we have to hold it to the touch.
Okay, one
Yeah.
more time.
Yeah.
Okay, ready? One more time.
A couple of weeks. This is not an Amiibo.
Yeah, I know. It can be finicky.
Try rotating it this way. Putting it flat against the touch pad.
Yeah, one more time. Okay. No, it should be still working. Why is it not?
The wires actually accept.
Yeah. Here, we'll restart this. Oops, there. One more time. Okay, one more time. There we go, registering. Oh.
Oh, maybe we already got it. Because it went earlier. Maybe if we just go to like the fiber screen and we type it.
We'll just start this again. Seems to work once and then, oh, it's emulator stop, that's why, yes. All right, one more time. Register. Keeps failing for some reason.
The gods of-
The gods of the demo god just got us.
Yeah.
But we got halfway through, so I swear this works. There, we got it. Woo! Lucino?
Yeah, we got Lucina.
Okay, excellent.
Yeah.
All right, we just made our own amiibo using the anyway, that's the coolest NFC hack I can think of. All right, so let's finish this up.
I have a question.
Yes.
About NFC, I've got this clicker card here.
Yeah.
I just scanned it. It seems to be my fare. I feel like it's encrypted, right?
It is encrypted, and if they did it right, I had troubles. I looked at the clipper card a long time ago, and I had trouble getting into it. If they did it right, it should be they should be storing your data on the server. But there have been times when people have given out transit cards, and you can totally hack those to pieces. They'll store the data on the card, and even if you can't decrypt it, what people will do is they'll put up someone else's card to like read the value off of it. Like let's say there's $1 in your card and like $50 on another person's card. They'd read the other person's card, and then they would say add $1, and then they would put their card to write onto it, and then they would get the value that was on the other person's card. So yeah,
Interesting. Can you do that on the fast track?
no, I don't think so. I haven't checked it out. I mean, you would hope in Silicon Valley we have things, but we can take a look at that after the presentation if you want to look at the Proxmark on that.
Yeah.
So anyways, there's a few other things you can do on the zipper, on the Flipper Zero, but that do not involve radio. So there's like a bad USB, so it can act like a keyboard and send commands, pre-supplied commands. There's GPIO pins, so you can run LEDs and stuff. This is something weird. I've never seen this before, and I don't know where this has come from, but apparently it's a thing. There's a thing called an I button, and it uses like a one-wire interface. And I've only seen these for like one wire, used for things like measuring sensors off like one wire to like a microcontroller. And apparently it's used for something, I don't know what. I've never seen an I button before, but apparently it supports it. If anyone has an I button, something I'd love to see it work. There's a command line interface. If you plug your Flipper Zero into the computer, you can open up a COM port, get a serial interface going. And of course, there's Bluetooth if you want to connect your Flipper Zero to an app, but the Flipper Zero, as far as I know, does not actually hack Bluetooth, which is kind of a disappointment.
It does.
Oh, it does. Okay, never mind. All right. Okay, never mind. So we've done that then. So in conclusion, yeah. So whenever the Flipper Zero does something, there's always something that'll do something like better. So we saw for like infrared, you can get those little cheap infrared dongles you can put onto microcontrollers to get a really deep dive. But the Flipper Zero will do like basic stuff. That's cool. For sub-gigahertz stuff, yeah, so yeah, it can record signals from like, a doorbell or a Tesla, a Tesla thing. But if you actually like have things like rolling codes, or if you're doing more detailed signal analysis, you'll probably want to use like a hack RF SDR. But for basic stuff, yeah, it's fine. For RFID or NFC, just get a Proxmark. Like, forget about the zipper, the Flipper. Get a Proxmark. They're awesome. As we saw, we got an amiibo, made our own amiibo. But it combines all those things into one little package that you can carry in your pocket. So, good times. Anyway, there's plenty of stuff to play around in here. So let's keep hacking.
Really quick, what is called the bad USB. So.
Oh, you want to look at the bad USB?
Yeah.
Come on up here. Come on, let's look at the bad USB. I have a USB cable all ready to go.
Awesome. So in case you didn't know, the bad USB module comes from the what is it? The was
The
it batch
rubber
body?
ducky, yeah.
No, the rubber ducky from Hack 5. So if you already know how, you know, or previously, if you use Hack 5 products like the bash body, or what is it? The
Rubber ducky.
rubber ducky, sorry. Yeah, I always get confused with those. Yeah, you basically can use it. So it is very simple. So I'll give it a shot. I gave this presentation a few weeks ago at the CTF. You know, but I really wanted to show you guys. So a second here. So what it does is,
You can unplug that.
that's all right. Here. Is it all ready to go?
Yeah.
Or?
Yeah.
Okay, gotcha. So right now, because she's using VMware, we have to tell her what we want it to run. So we just go to the connect to host. We don't want it to any virtual machine. And then all I have to do is run. And as you know, you can do multiple stuff, but in this case, we're just gonna run the demo version of the Windows. So here it is. It will open a notepad. It will start creating some stuff. And then it will start writing off the sweeper.
So it's basically pretending to be a keyboard, but you could use it to send in any commands you want. So in this case, open Notepad and do a flipper, but you know, we can have it download, I don't know, interpreter, whatever you want.
Yeah. So I'll run again because you probably didn't see it. So here, it's gonna open Notepad. Then it's gonna start writing everything. And again, the scripts, I don't know if you saw it on the bottom of the screen. That's where you get all the scripts. So you can just load them in here. And you know, it's actually very useful if you're in the IT industry and you're just running scripts and you want a place to store it, you know, this is probably it. I'm not saying it's a good idea, I'm just saying it might be useful. So what else? Yeah, I think that's it. There's also a demo for Mac. So we showed that before, the Mac version. And that's it. So with that, Kaitlyn, thank you so much. Again, we don't have a meetup set up yet for September or October. November, we're not gonna have a meetup because we're gonna do the conference. But September and October, we need to add some meetups there. So if anyone is interested in showcase something, please send an email to, in fact, I'll put it right here. So Marco at Pacific Hackers, or I'll give you my business card. You know, so send me an email there and tell me what you want to present on. If you have a project, if you have a competition or whatever, please let us know. Again, for the people who were not here earlier, we have t-shirts for sale to support the nonprofit. One for 25, two for 40. And if not, we can call it a day. Any questions from the other side of the world? Rod, anyone from?
Thank you, Kaitlyn. Thank you very much.
The net?
Oh, they're saying thanks. Oh, there's a question.
Great presentation.
What
Thank you very
kind of
much.
specific tactics, besides keeping away from your device, can be used to protect Windows against bad USB on Windows? Yes, so you actually can go into group policies and prevent those types of attacks. It is an obnoxious process, but you can do it.
I can add into that. So if your company has, that's a group policy or settings in your local machine. But if you're in an enterprise, get an EDR solution, and they also have bad or USBs policies there as well. The first part.
So what do? You only allow certain USB devices?
Potentially, or actually will detect what type of of keyboard it is, and then you can go from there. Also, it works with behavior, so depending on what it's trying to type, we can go from there.
I've also seen projects that look at the frequency of the keys being pressed So if the keys are being pressed every, 1 millisecond or every 5 milliseconds, it knows it must be a robot, and then it'll block it. But that's easy to, get around. Yeah, set random place. So.
I have a little piece of information about the I button.
Yes. Oh, please.
So
I want to know all about this.
Was a little device by Dallas Big 100 phones from Dallas. And this had a little chip, which was a Java card, particular chip, like you have on the Java smart cards years ago. You could program it in like 1 K of in Java. It runs a KVM, like a Java JVM, but with KVM, it's a bit smaller. And then it used the one-wire protocol, which is sort of serial, but TX and RX are on the same wire. So it's like one wire. Of course, there is ground, so there's 2 wires. But yeah, so you can program. They were used to store like a key or something.
Yeah, I've never seen them in the wild. But the Flipper Zero was made in Eastern Europe, so there's a good chance that a lot of the technologies that it focuses on are popular over there, but not over here.
There's only one place I ever see smart button in the wild. It's still used by security companies.
Really?
They'll randomly stick it up on like the corner of a building. And if they have a guard who's on patrol, they want the guards to basically touch a thing to it to mark that they were at this point at that time. And that's basically how they keep track of where their guards have been to make sure that they're patrolling.
Oh, that is interesting.
But I think security companies use that because they've been using it for like 20 plus years. Because I saw it 20 years ago, and I still see them stuck in buildings occasionally. It looks like somebody just randomly stuck a really large button cell battery on the side of a building.
I've seen in an apartment building double.
Oh, cool.
You can find sometimes on eBay. That's a really a collectible. It's a ring, like a finger ring that has a I button on it. Big jump. And there are SDKs and everything you can find program.
There was one question about the AirSpy.
Oh, the AirSpy. So yeah, let's go to the AirSpy website. Okay. So there's only like 3 modes of AirSpy that you can get here. So if we go to the AirSpy website, you can go to purchase. Airspy.us is where I got mine. And the demo gods got us again. Airspy.us appears to be down or very slow. Oh, there we go. Okay. So if you go onto their products, you'll see that there's some SDR receivers. And here we go. So there's like the SDR Mini, which is sort of the competitor to like the RTL devices for 100. The one I have here, the AirSpy R2 is 170. And then the HF, this one right here, it's another $170, but that one does the lower frequencies. So, yeah, SDRs can get really expensive when you start getting into the really good ones. So the one that I really like is called the Blade RF. And this is only if you're like getting into like signal processing and making your own RF hardware. But it goes all the way up to, it has 2 transmit antennas, 2 receive antennas. You can turn it into a Wi-Fi hotspot. I kid you not, there's a there is a FPGA on board, and you can actually turn your SDR into a Wi-Fi hotspot, and they have the code to do it right here. But it is a little expensive. So we go to the shop. We see that they start at about $540, go up to $780, and if you want to blast it off into space and you need a thermal version, it costs you like $1,600 or more. So. But they're awesome. I love those later. That should give you an idea about how the AirSpy prices compared to the other professional SDR hardware. All right, let's see, any other questions? Yeah, I said the AirSpy that we used was the AirSpy R2 for the 433, the sub-gigahertz, and then the AirSpy HF for looking at the RFID stuff.
Is the blade RF expensive because of any hardware that's inside of it, or is it the software and all that they put in?
It's entirely the hardware. Like I said, so if we go back to the Blade RF website. There's a lot of RF engineering that goes on. So when you're designing RF devices, it's a little bit different than designing traditional like analog or digital devices, because you have to be very particular about what goes on in the entire signal path. And there's a lot of signal paths. So you have to make sure that there's low noise being brought in, because you have a lot of like amplifiers, for example. You need to make sure that the timing circuits are, going to be as precise as possible. So you need something, you can't just have a regular old crystal oscillator. You at least need a temperature controlled or temperature compensated crystal oscillator. And of course you need to keep in track of like impedances and stuff like that. But if we look at the image right here, you'll see that there's a giant FPGA right in the center here, like Cyclone. And these things are really expensive. So you have a lot of expensive RF hardware, shielded of course, and you have 2 receive signal paths, 2 transmit signal paths, and also a really expensive FPGA that you're working with. So that's why it's so expensive. I mean, it really does cost that much. But you can, SDRs are the radio equivalent of FPGAs in the digital world, if anyone's ever used those. And of course, this also has an FPGA, so it's like double as expensive.
Where would they use these expensive?
So if, let's say you're designing your own RF systems, like you are designing a new product and you want to like design a new Wi-Fi chip, you would actually get something like this. And like I said, you can actually load up the FPGA with software that will turn this entire device into a Wi-Fi router that you have full control over. You can also turn this into, like, let's say you're developing a doorbell and you want it to run on like 433, 0.92 megahertz, and you're designing the circuitry. That's where this would come in. So if you're doing RF design, instead of building an RF circuit by hand, you can use this to sort of simplify the process and do everything in software.
But I wonder, like, would they use it in drones application?
What like application they would use to develop? So
What
for
application would use this kind of RF device?
like what, so to program the FPGA, you're going to use something like Xilinx or their software. And then, but for radio programming, you would use something like GNU Radio or Simulink and MATLAB. And then you can take those specs and implement that on a much cheaper solution if you're going to scale it up.
Oh, I mean, commercial application, I don't mean as software application.
Like-
Where are these boards being used commercially?
Right, so these are used in development. So if you are developing a new piece of hardware.
I see, for
Yeah.
prototypes.
Yeah, for prototyping,
Okay.
yeah.
Or to make a web SDR, for example.
And like a web SDR, this is like way overkill. I mean, it's awesome if you want to use this, but like an AirSpy would be better for like a web SDR. But like I said, if you're doing any like RF development, you gotta use something like this. Any other questions? All right.
All right, thank you. Yeah, that's it, guys. So thank you so much for coming, and yeah, we'll see each other hopefully next month, and we'll get a new cool presentation like this. And if not, submit your, we want some input from you. So again, please let us know what you want to hear, what you want to see,
And we have plenty of
I'll find the speakers. Just tell me.
Yeah, we have plenty of stuff to play with up here, so.